Okay, students, today we are talking about the temperature dependence of resistance. So, if we take a material and if we increase the temperature of the material, what will happen? We will see that one. So, say suppose the temperature of a material increased, two cases are possible. Case 1 is number of free electrons will be increased. Case 2 is number of collisions will be increased. Suppose let us write that point. If temperature of any material two cases are possible. Case 1, number of free electrons increase. Whenever the number of free electrons are increased, automatically the conductivity of the material increase. So conductivity increase and resistance or resistivity of the material decrease. Okay, this is case 1, and case 2 is the number of collisions. That means whenever the temperature increased, the ions in the material vibrate with the maximum amplitude, and then due to this they will collide with the free electrons. So number of collisions between electrons and ions will be increased. Number of collisions between electrons, I mean free electrons, and ions will be increased. So the resistance and resistivity will be increased. Resistance or resistivity will be increased. So say these two cases are possible. So if we take conductors, what will happen? Conductors, what will happen? Conductors already have free electrons, so there is no scope to increase in the free electrons. The collisions will be increased more. So case 2 is more dominant than case 1. So the resistance and resistivity will be increased when the temperature increased in the conductors. Let us write that point. If the temperature increase, if temperature increase, case 2 more dominant than case 1. Dominant than case 1. So whenever it is more dominant case 1, the resistance or resistivity will be increased. Resistance or and resistivity rho will be increased. So see, if we take semiconductors, so if temperature increase, what will happen? In room temperature, the semiconductors have only very few free electrons. With the temperature increase, the number of free electrons are more increased. So case 1 is more dominant than case 2. Case 1 is more dominant than case 2. So the conductivity increase in resistance and resistivity will be decreased. Resistance and resistivity will be decreased. Okay, now this how it will be increased or decreased the resistance or resistivity. The formula for this is represented as RT is equal to R naught into 1 plus alpha T minus T naught, or the resistivity rho T is equal to rho naught into 1 plus alpha into T minus T naught. So before the temperature, the initial temperature, this one T naught is the initial temperature, T is the final temperature, this is the temperature difference, and alpha is the temperature coefficient of the material, and rho naught or R naught is the initial resistance or resistivity of that material. These are the final resultant resistance and resistivities of the material. So this formula is used whenever the temperature is increased to find the resultant resistance or resistivity. Okay, so let us write this point. Alpha is temperature coefficient of resistivity. Temperature coefficient of resistivity, and the temperature difference T minus T naught is temperature difference. So let us do some problems on this formulas.